Hello, can you hear me?
Just so we can have picture.
Uh, okay, let us start a new technique which is branch and bound. Okay, so we will try to understand with one example and then let us try with this one. We have to learn two techniques. In branch and bound technique, we have to learn two algorithms. One is 15 puzzle and another one is uh, 01 knapsack probably in your syllabus. So today we will try to discuss this technique 15 puzzle problem as it's a very well known problem. All of you are familiar with this. So let us try with this 15 puzzle problem. Okay. So let us consider that an given instance just okay. Let us consider that puzzle is given. On this puzzle, the numbers are initially say uh, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So this is the given puzzle. So this is the given instance. Now, what is our objective or our final solution is? So our goal is to solve this problem. The goal is this one, while the numbers are in order according to their values. So here our objective is this one. So from this given problem, you have to rearrange them. So this is the final result or goal of this solution. So in this goal, the numbers will be in their order. So 3, 4, 5, 6, 7, 8, 15. And this one is blank. Okay. So from this given problem, we have to rearrange them in such a way so that this goal is being achieved. Okay. So how to solve this problem? As we know that if in this problem, this is the blank space. So based on the position of the blank space, some moves are possible. Okay. So initially we can move this 4 to this blank space. Alternatively, 7 can move there or 3 can move there. So at this moment, there are 3 possible moves. But if this blank space is in some, it is not in one side, like this one, instead of 7, if this is the blank space, then there will be 4 possible moves. Okay. Now, so based on the space or free space, we have to decide the moves, and performing some moves we can finally reach this goal. Okay, so this is the given problem. So from this given problem we have to reach here. So what is our objective? Using minimum number of moves we have to reach this goal. Okay, so how to solve this problem? So this 15 puzzle problem is basically in this 15 puzzle problem, we have to think in two aspects. One is, if you purchase a puzzle from market, then initially all the items are arranged. So you will, when they will sell this puzzle to you, then generally you will get it in this form. Okay. Now, if you randomly move those items, then after moving or performing some random moves, you will get an instance. Now, on this instance, if this instance is being given to someone, he has to solve it. Okay. So what will be the minimum number of moves for solving this problem that can be decided? Another thing is, instead of purchasing it from the market, if I give you a random sequence like this one, here when we are generating this one, we are putting the items randomly. So if you put those items or numbers randomly on this 16 4x4 board, okay, so there are 16 positions. So if you put those items randomly, it may happen that there is no solution for the given puzzle. Okay, the situation may be like this one, that there may not exist any solution for this given puzzle. Okay, so first, so you have to think in two aspects. One is, first we have to check whether this problem is solvable, and another thing is, if it's solvable, then performing what a sequence of moves you have to perform on your given puzzle to reach this goal. So what are the sequence of movements that needs to be determined? And always we will try to reach this goal in minimum time. So what will be, from algorithmic perspective, first we will try to validate whether this given instance or puzzle is solvable or not. Okay. So if you want to validate it, so how to check it? So to validate this one, we have to proceed in this way. For each and every element present in this given puzzle, we have to calculate the lesser values. So if we define a function less, okay, less I. So what will be the value of less I? Less I is basically a value which represents number of elements which are residing after this element, okay, which are residing after this element and which are less than this value I. What does it mean? So let us check it. So how to decide this value? So if we say less, what is the first element? First element is 4. So what will be the value of less 4? Less 4 is basically the number of elements. So if we represent this array in one dimensional array, so if we consider row measure ordering, okay, so if we consider this row measure ordering, let us put those items. So first one is 4, then 2, then 1, 9, then there is a blank space, 7, 8, 15, then 3, 14, 5, 12, 11, 10, 13, and 6. Okay, this is the row measure representation. So in this representation, What is the value of less 4? Basically, the value of less 4 is number of items which are present in the right hand side and less than this value. So how many items are there after 4? How many items are there which are less than 4? Just a minute, I have to receive a call. না, MySQL এ তুমি বাই ডিফল্ট 0 সেট করতে পারো। তুমি এক কাজ করো, তুমি আপাতত নাল রেখে দাও। ডিফল্ট বলে একটা কোয়ারি সেট করা যায়। তুমি একটা কাজ করো, আমি একটু ক্লাস নিচ্ছি, আমি তোমাকে একটু পরে কানেক্ট করছি। তুমি ওটাকে আপাতত নাল দিয়ে করো, আমি কানেক্ট করছি। ঠিক আছে? Okay. So here, less 4 means how many items are present on the right hand side which are less than 4. There are 3 items, 2, 1 and 3. So this value less 4 is basically 3. Then the next item is 2. So what will be the value of less 2? Less 2 is basically after this 2, how many items are there which are less than 2? Only 1. So less 2 is 1. Now the next item is less 1. So less 1, there is no element which is less than 1. So it's less 1 is 0. Then less 9. What will be the value of less 9? 7 is lesser than 9. Then 8 is lesser than 9. So 2, 3 is lesser than 9. So 3 items. 5 is lesser than this. So 4 items and 6. So 5 items are there. So 5 items are there. So this less 9 equals to 5. Okay. Is there any doubt up to this?
Sir, less function টা একটু বোঝাবেন, less function কি হলো কি করে?
Less function is basically less I means the number of items present on the right hand side of I which are less than I. Number of items, so less I is basically it is number of items present in the right hand side of I, okay, which are less than I. Is it clear now?
Yes, sir.
Okay.
Yes.
Number of items present in the right hand side of I and which are less than I. That count of those numbers which are lesser than this current value. So what will be less 7? Less 7, 8, 15, 3. 3 is lesser than 7. 5 is lesser than 7. So two numbers. Then 6 is lesser than 7. So less than 7 is basically 3 items. Then check this value for next item. Okay. So in this way you have to calculate all the values. Okay. Up to, so you have to continue up to less 15. Okay. For all the items you have to calculate it. So what will be the, just for the last one, what will be the value? Less 15. 1, 2, 3, 4, 5, 6, 7, 8. So 8 items are present which are less than 15, which are in the right hand side of 15. So this is 8. Okay. So after calculating these values, Now you have to calculate sum of them. Okay. Now here we have to calculate sum. So if you calculate sum over I, so I means I equals to 1 up to 15 for this given in problem. So I equals to 1 to 15. You have to calculate sum of this less I. So 3 plus 1 plus 0 plus 5 plus 3, and in this way up to this less 15. So if you calculate sum of these numbers, you will get some value. Okay. After getting this value, now we have to validate this problem, whether the problem can be solved or not. So I will use another board. Okay, I will use this board. Now, alternative positions of this board is basically shaded. So if we say that this one, so here this one is shaded, then one after another. So this is shaded. Okay, so these are the shaded positions. Okay, now along with this one, you have to add a number. Say this number is x. So what is the value of x? X is basically you have to check whether this blank space in your given input, whether this blank space is present on this shade or on white space. So x, this value x, the value can be 1 or 0. Okay, so it's a Boolean variable. It's a Boolean variable. So when this value is 1, the value of this one is 1 if this empty spot, if this empty spot is on this shaded position. So this value is 1 if empty cell on the given board, if the empty cell on the given board is on shaded position. Okay, so this value is 1 if empty cell on the given board is on shaded position. Otherwise, this value is 0. So for this given instance, what will be the value of x? Here the value of x is 1. Okay, so value of x is 1. So this value x is 1, and you will calculate this value sum of less I. After calculating this value and x, if this value, you will get some result. Okay, you will get some result. Now if this result,
স্যার বলছি ওই শেডেড যে বক্সটা করলেন 15 পাজেলের সেটার পর থেকে না
if okay, basically here we are discussing that first we have to check or validate whether this given input is solvable or not. So how to validate this one? So to validate this problem, basically here what we have to do, here we have to calculate the sum of these lesser values. So that will be calculated by this equation. Along with this, you have to add this value x. So what is the value x? X is basically, if we have these shaded boxes, okay, so alternative positions are shaded on this board. So if this blank space, what is the position of this one? This empty position or empty cell, it's a second row first column. Okay. Now here, this second row first column, this is shaded. This 2 1, this position is shaded. If this is shaded position, then you have to add 1. So the value of x is 1. If in the given input, this empty cell is on white position, okay, the corresponding cell of this empty cell is white, then 0 will be added. The value of x will be 0. Okay. Now, after calculating this value, if the result is even number, if the result is even, then we have a solution. If the result is even, then there exists a solution. Okay, there exists a solution, or we can say, or the problem is solvable. The 15 puzzle problem, this 15 puzzle problem is solvable. Okay, but if this value is, instead of, if this value is odd, if you get this result after calculating this, if the result is odd number, there do not exist any solution. If this is odd, then the 15 puzzle problem, the problem is not solvable. Do you understand what we are trying to say? So if this number, if this result is even number, then there exists a solution. If this result is odd, then they do not have any solution. Whether this problem is clear or not. There is a mathematical proof, but we don't need to, because this one is not included in your syllabus, so we are not going to discuss the mathematical proof. But the theorem is, if you calculate these lesser values and if you determine the value of x, if this result is even number, then the problem is solvable. Otherwise, the problem cannot be solved. Now, if you purchase a board or 15 puzzle from the market, then obviously initially this one is solved. So whatever movements you have performed using the reverse movements, you will get the solution. Okay, so you can solve this problem using the reverse movement. Now, if you generate this board, if you write a program to generate this board, okay, so you will put the items randomly in different positions. So there may exist an instance, you may generate an instance which is not solvable at all. Okay, so this is the problem. Is there any doubt up to this? Is there any doubt? Are you connected?
Yes, sir. No doubt.
Okay. So this is one part of this problem. Now we'll discuss the next part. Okay. So if this problem is solvable, then how to solve this one? Within minimum number of moves, how will you get this solution, or you will be able to reach your goal? So as time is limited and we have a very limited space on this board. That's why we'll try to solve a simpler problem. I will not take this one as an example. So I will take a simpler one to solve this. Let us solve this one. Just a minute. Okay. One. One, two, three, 4, 5, 6, 7, 8. Okay, let us take this example. Okay, so we can validate this problem is solvable. Okay, so if you move 7 in the upward direction, 7 in the upward direction, then 11 can be shifted in the left hand side and 12 can be shifted in the upward direction. So basically this problem is solvable. Now if the problem is solvable, then okay, let us validate this one. Do you have any doubt in the previous function? If you have any doubt, then with this one I can show you that this problem is solvable. Otherwise we can move to the next algorithm. So here you will get that the less of 1 is 0, less of 2 is 0, less of 3 is again 0, less of 4 is 0, less of 5 is 0, less of 6 is 0, less of 8 is 1, because only 7 is in the right hand side, less of 9 is 1, less of 10 is 1, less of 11 is 0, less of 12 is 0, less of 13 equals to 1, less of 14 is 1, less of 15 is 1. So if you calculate this sum, this value will be, and if you add x with this one, then the value is even number. Okay, so the problem is solvable. So if the problem is solvable, how to solve it? So first, what are the possible moves? So 3 can move in the downward direction. Okay, 8 can move on the left hand side. Okay, 6 can move to the right position and 7 can be shifted in upward direction. Okay, so there are 4 possible moves. So if this space is moving in the upward direction, so what are the possibilities? So this is upward direction. There will be another instance which is upward, then say it's a right movement, then after Then if we set down movement, and another possible movement is there, and this is up, right, down, and sets a left. Okay. Now, what will be the instance after this first movement? Okay, you can take a break. I will draw this on. But if you take a break, then ensure that you will join within 5 minutes. So if it's a upward movement, then 3 will be placed here. If it's a right movement,
তো বলছি এই তো নিচে নামলো, তাহলে ওটা ডাউনওয়ার্ড মুভমেন্ট হবে না?
হ্যাঁ বলো।
ব্ল্যাঙ্ক ব্ল্যাঙ্ক বক্সটার কি মুভমেন্টটা
ব্ল্যাঙ্ক
বলছেন স্যার?
ব্লকস এর মুভমেন্টের উপর ডিপেন্ড করছে।
হ্যাঁ,
হ্যাঁ,
ব্ল্যাঙ্ক
সেই হিসাবে হচ্ছে maybe।
দেখো অ্যাকচুয়ালি বক্স তো ব্ল্যাঙ্ক পজিশন তো আর, মানে আমরা পজিশনের মুভমেন্ট বলছি, বাট অ্যাকচুয়ালি ব্ল্যাঙ্ক পজিশনে তো কিছু থাকে না, আইটেমটা মুভ করে, বাট পজিশন ইজ, উই আর কনসিডারিং দ্য পজিশন ইজ মুভিং।
হুম, ঠিক আছে।
ঠিক আছে, 6 সেখানে যাবে, 6 সেখানে গেলে this is the blank space. Okay, now I have to put those items. So 1 2 4 1 2 5 6 8 9. Sorry, this is 7 and this is 11 13 14 15 12. It's 5 6 7 8 10 11 5 6 5 So this value is just a minute. This value is 12. So this is 12. So after this movement, now these are the instances which are being generated. So we have 4 possible moves. Now, for every instance, this one is the given problem. So if this is the given instance, for this given problem, we have to check the distance from the goal. Okay, so distance from the goal means how many items are there. Distance from the goal means how many items are there which are not in appropriate position. So that will be the distance of the instance from the goal. So what will be the distance of the first instance from the goal? Let us check this. So distance is basically the distance of the first instance. Okay, distance of this current instance is how many items are not in appropriate position. 1 is in appropriate position, 2 is in appropriate position, 3, 4, 5, 6, 8 is in appropriate position, 9, 10, 7 is not in appropriate position.
Two.
So 7 is not in appropriate position, then 11 is not in appropriate position, then 13, 14, 15, then 12 is not in appropriate position. Is it, or I have missed something? 8 is it in its appropriate position, 9, 10, 11, so 1, 12, 2, 13, 14, 15, and 12. So this value is 3. So distance of this given instance from the objective or goal is basically 3. So this distance is 3. Now calculate the distance for the instance. What will be the value? 1, 2, 4,
হাতের জন্য 4 হবে
5, 6, then 3. So for 3, 1, 8, 9, 10, 7, 11, and 12. So this value is, so the distance is 4 here. Now from this given instance, what will be the distance? Again, this distance is 4. Okay, here the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. So distance is 2. Here the distance is 6, 7, 11. I think the distance is 4. Okay, so if you calculate the distance of each and every instance from the objective function, then which one is minimum? This value is the minimum. As this is the minimum value, you have to accept it. Okay, so accept this result and create the branches from this instance. So in the next level, branching will be performed on this branch. Okay, so as the name suggests, the algorithm is basically known as branch and bound. So as name suggests, you can understand what is branching. So when from an instance you are generating the next instance, so it's a branching. Now what is bound? So bound is here. So if we consider this algorithm, what will be the total search space to get a solution? Total search space of this algorithm, if we consider search space of this algorithm. So what will be the search space? Search space is all the possible instances. So what will be the search space? So if we use recursion for all the possible instances or possible moves, then you need huge volume of memory, which is very difficult to manage in your definite system. Okay, so if we want to solve this problem, then first we need to understand what will be the search space. So here, what will be the search space? So if it's a board is given, none of these elements are placed on this board. Okay, so you can put one in any position of 16 available spaces. So first item 1 can be placed at one position where all the places are free. So 1 can be placed in 16 different positions. Now once you have placed 1, then second item or item 2 can be placed in any position which are not occupied. So after placing 1, 15 positions are free. So if 15 positions are free, you can place item 2 in any one of these 15 positions. So all the possible combinations are, it will be multiplied by, so possibilities are 16 multiplied by 15. Then remaining places are 14. So if you put third item can be placed in one position of available 14 places. So it will be multiplied by 14. So in that way, it will run up to 1. So the search space is basically factorial of 16, which is very large value. Okay, so we can't solve it in that way. So what we have to do, so when we are creating the branches, immediately we have to bound it. After creating these branches, we have to bound it. So what is the bounding? So here we are calculating the distance of each and every instance which are being generated at this moment. So what are the instances? So this is one instance, this is another instance, this is another instance. So for each and every instance, calculate the distance. Among them, which one is minimum, only that will be accepted, and next level of branching will be performed on it. For other branches, this expansion or branching will not be performed. Do you understand the problem? So in that way, we can reduce number of branches. So if we reduce this number of branches, then search space is being reduced. We are limiting the search space. Okay. Now, from this one, let us create next level of branching. So, can you draw these boxes on behalf of me? Okay. Then, what are the possible moves? Here, how many possible moves are there from this instance? Any answer?
আপসাইড মুভমেন্ট ছাড়া তিনটে মুভমেন্ট, কারণ ওটা আগে একবার ওটা থেকে এসেছে এটা।
So another criteria is we will not perform upward movement. If we move this item in the upward direction, basically it will generate this instance. So again, it's redundant. So after performing two movements, we are returning to the previous one. So that is redundant. So except the upward direction. So here, if we use downward movement, when this instance is generated by performing down movement, then up movement will be restricted. If you accept an instance or you have received this instance by right movement, then left movement will be restricted. So opposite movement will be restricted. By which movement you have generated this instance, opposite movement will be restricted. So that's why we will not perform upward movement. So here it will be left, then down and right. So these are the possible moves. So here, after this, what will be the value? 1, 2, 3, 4, 5, 6, 7, 8. It's a left movement. So 10 will be shifted here. Now this value is 11, 12, 13, 14, and 15. This is down movement. So 15 will be there. So 1, 2, 9, 10, 11, 13, 14. This is 12. Here's the value is 1, 2, 3. From this instance, it's a right movement. So 11, this is blank, 13, 14, 15, and 12. Okay. Now again calculate the distance. So for this one, what will be the value of this distance? 1, 2, 3.
3.
3. So this distance is 3. Here
It will also be 3.
it will be 3. And here 9, 10, 11.
1.
This value is 1. So which one is minimum? This one is the minimum. So if this is the minimum, then reject others. Okay. So reject others. Now in the next level, expand. You have to expand this one. So what are the possible moves? So it can move in the upward direction. We have to avoid the left movement as it is received by right shift. স্বপন গলাটা বোঝা যাচ্ছে না। হ্যালো,
না স্যার আমি বলিনি কিছু।
কে বলছো? কেউ কিছু বলছিলে? হ্যালো,
মেবি স্যার ওটা কোনো ব্যাকগ্রাউন্ড ভয়েস, ছেড়ে দিন।
okay. So what are the possible moves from this position? It can move in the upward direction. Left is restricted because it is being received by right shifting. So left is restricted. So we have one upward movement and one downward movement. Whereas right side position is invalid position. So right side is again restricted. So we have two possible moves. One is 8 can move here or 12 can move here. So there are two possible moves. I should take little bit smaller examples. Okay. Okay. Okay, so one is upward direction, another one is down. Okay, so after this movement, it will be 1, 2, 3, 4, sorry, 5, 6, 7, 8, 9, 10, 11. It's an upward movement, so it will be 8, 13, 14, 15, and 12. And by this downward movement, 1, 2, 3, 4, 10, 12, 13, 15, and this is the blank. Now calculate the distance. For this one, obviously the distance is 0, and for this one, 1. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 2. Okay, so the distance is 2 here, and this distance is 0. So if the distance is 0, you have reached your goal. So this is the goal or objective of this algorithm. So in that way, from a given problem, you can solve it. So instead of performing all the possible or searching this solution in the total search space, we can reduce it. And this reduction can be performed in this way. Okay. That's why this technique is known as branch and bound. Now, another question is, for any given instance, if you calculate the distance, and if the distance is, for this example, the distance is 3. If the distance is 3, then what is the measure? What we can conclude? We can conclude that at least 3 moves are required to reach the goal, but not exactly. At least 3 moves are required. For any instance, we can write here. For any instance, if distance is y, the distance is y, then at least y number of moves are required. To reach the goal. This is another theorem. At least y number of moves are required. For any instance, if the distance is this, at least this number of moves are required. Is there any doubt in this algorithm? Is there any doubt?
No, sir.
না স্যার।
আচ্ছা, তোমাদের এখনো কি কেউ কেটে দিচ্ছে, মানে বের করে দিচ্ছে এখান থেকে, নাকি তোমাদের ইন্টারনেট কানেকশনের জন্য প্রবলেম হচ্ছে?
না স্যার, বের করে দিচ্ছে।
আমাকে
বের করে দিচ্ছে। তো অনেকবারই বের করেছে, দুবার বার করলো, 2-3 বার।
সৌপর্ণ আপনাকে প্রশ্ন জিজ্ঞেস করলো, তারপর তাকে বার করে দিয়েছে।
তাহলে সব থেকে ভালো হয় আমি ইউটিউবের ওই ভিডিওগুলো, মানে এই ভিডিও নয়, ইউটিউবে যেগুলো পাচ্ছ সেগুলো থেকে পড়ে নাও, বুঝে নাও, সব থেকে ভালো হবে।
না স্যার, আপনি স্যার জুমে পড়ান না।
স্যার আপনি জুমে ক্লাস নিতে পারেন। হ্যাঁ স্যার জুমে।
এটা নিতেই পারি, সেটাতে প্রবলেম কিছু নেই, ইলেকট্রনিক্সে তো জুমেই নিতে হচ্ছে।
হ্যাঁ স্যার আপনি জুমেই ক্লাস নিন, তাহলে কেউ বার করতে পারবে না।
তোমাদের ইন্টারনেট কানেকশন নিয়ে প্রবলেম হচ্ছে সেই জন্যই।
স্যার স্কাইপে ক্লাস করতে পারছে তো জুমেও ক্লাস করতেই পারবে সবাই।
স্যার সিসকো যেটা একটা আলাদা অ্যাপ আছে, ওটাই কিন্তু মানে জুমের মতোই ভালো। ওটা কি